Our objective today is that we are going to find definite integrals as opposed to indefinite ones using the fundamental theorem of calculus. The fundamental theorem in this case is going to tell us that if we're taking the integral of a function and we have limits, so a lower limit a and an upper limit b, that is equal to whatever we integrate, plug in the upper limit and subtract the same thing when we plug in the lower limit. So very, very important idea. We're going to be using this the rest of the year. In this first case, we've got the integral of 3x squared dx from 1 to 5. And let's just start by finding the antiderivative. So the antiderivative of 3x squared, of course, is just x cubed. I'm going to write this in parentheses. We don't need plus c's here because we're going to calculate the actual distance or the area between them. And then we write a vertical bar with a 1 and a 5 at the end to show we still need to evaluate this at 1 and 5. So I recommend doing this with brackets. You'll see what I mean in a second. So we start by plugging in the upper limit. In this case, that's 5. So this is going to be 5 to the third. And then we subtract what we get when we plug in the lower limit. So this is minus 1 to the third. The reason I recommend brackets is sometimes you have a lot of extra terms in parentheses, and brackets just make it really obvious where the upper limit plugged in minus the lower limit plugged in is. It's very easy to make mistakes here when these are more complicated than this first one. So in this case, this is 125 minus 1, so that comes out to 124. You can check this, of course, on the calculator because it's a numerical answer and not an algebraic one. And what this says is that the area under this specific curve between 1 and 5 is this exact amount. Our next problem is the integral of 8x plus 1 over x squared from 1 to 3. And this one will be a little more complicated, so we're going to start by taking the antiderivative. The antiderivative of 8x is 4x squared. And then I'm going to think of this as 1x to the negative 2. So when I do that, I get plus negative 1x to the negative 1, which I'm going to write like this. You do not need to write it like this. I'm just doing it like that because I think it's going to make it a little nicer for what I'm about to do. I'm going to put the line that goes from 1 to 3. And now we can actually plug in our upper and lower limit. So upper limit plugged in, this is going to be 4 times 3 squared, and then minus 1/3, minus lower limit plugged in, which is going to be 4 times 1 squared, minus 1 over 1, so I'll just write 1. And then we're basically done. We've gotten a numerical answer. We're just going to simplify it as far as is convenient. So in this case, let's see, we've got 9 times 4 is 36. So we've got 36 minus 1/3. And then we have, this is going to be 4 minus 1 is 3, and then that's all minus 3. So this is minus 3. So it looks like our answer here is going to be 33 minus 1/3, so about 32 and 2/3. You could, of course, write this in different ways. Our next example is the integral of 5e to the x from 0 to 1. Start with the antiderivative of 5e to the x. Of course, it's very straightforward, just 5e to the x. This is from 0 to 1. And when we plug in our upper limit, we are getting 5e to the 1. Minus, plug in our lower limit, that's going to be 5e to the 0. I'm not going to turn this into a decimal, but I'm going to simplify it as far as I can. 5e to the 1 is just 5e. And then 5e to the 0, well, e to the 0 is 1, so this is just minus 5. And that's it for this one. If you needed to turn that into a decimal for some reason, obviously you could. So our last integral in this section, we can't integrate right now because there's no such thing as a quotient rule in for integration. So we're going to have to do some simplification first. 4x divided by x and 7 divided by x. So I'm going to start by doing that. I haven't integrated yet, so we still have integral from 1 to e squared. 4x over x is 4, and 7 over x is 7 over x. That does not simplify. Still have the dx at the end. And now we can actually integrate this. So the integral of 4 is 4x. The integral of 7 over x is 7 natural log of the absolute value of x. And then I'll put the bar. This goes from 1 to e squared. So we still need to evaluate this. When we plug in our upper limit, we have 4e squared plus 7 natural log of e squared. You might notice that I did not write absolute value there anymore because e squared is positive, so there's no need. All right, so that was our upper limit. Now we're subtracting our lower limit plugged in, so that's just going to be 4 plus 7 times natural log of 1. This one's going to come out a lot nicer than you might have thought. The reason is right here, natural log of e squared, those cancel out, and this is just going to end up being 2, so 7 times 2. And natural log of 1, you might know, is 0, so that all just disappears. So to simplify this a little bit, we have 4e squared plus 7 times 2, so that's plus 14, and then minus 4 because all that disappears. So to finish up, our answer is going to be 4e squared plus 10. Again, you can check this on the calculator. The calculator does find definite integrals for you in a couple of different ways.